Hello everyone, my name is Olintanovic, as Tatjana said, and today I will continue to talk about natural language processing pipelines. On our previous session, I talked about supervised learning, and before start with today's topic, unsupervised learning techniques, let me update you by a couple new updates on previous session documentation. One of our colleagues noticed that I missed to give an example of applying feature selection in our slide, and I fixed that. So there's the first update. Let me show you exactly that line here. So appliance of selected ABEX to reduce feature space for supervised learning. Also, testing report was not finished till the end of previous session. So I added the results of applied methodologies. So we applied neural networks and the light GBM and NLTK with the combination of TF-IDF and count vectorizers. So shortly, we here can see that our models significantly outperformed the NLTK pre-trained model, and results was not bad at all, about 96–97% of accuracy. So that's it for previous session. Today we will talk about unsupervised learning pipelines for natural language processing. In this session, we will not have a straightforward flowchart, which we had in supervised learning solutions, because it's really hard to standardize unsupervised learning approaches. Instead of flowchart, we will define some high-level pipeline and see what are our options for particular steps in that pipeline. After that, we will choose a couple options which we have on those steps and try an experiment to see what works best in our case. So let's start from high-level pipeline overview. High-level pipeline of unsupervised learning pretty much is similar as for supervised learning. We have pretty much same goals and as in supervised learning. So it's text cleaning, text vectorization, dimensionality reduction. Then we put vectorize and reduce text in machine learning algorithms. And at the end, we want to evaluate success and results of those models. So actually, first two steps are exactly same as for supervised learning. So I will not spend much time to explain them as we did that in the previous session. We will apply text cleaning in the same manner as for supervised learning. After cleaning text, we will apply for this session only count vectorizer, because we want to reduce complexity and the combination number of experiments which we prepare to do later. So cleaning text and the count vectorizer for this session. And the next step is to apply some of dimensionality reduction techniques. Here we are on a first decision-making point. Our options for dimensionality reduction in unsupervised learning are basically generalized in main two and third new modern option. So we have linear algorithms, non-linear algorithms, and last couple of years developed neural network and embedding layers. from linear algorithms, linear and non-linear algorithms, basically we can find almost all in sklearn, the composition and manifold modules. So let's choose one from all of those algorithms and methods. Most well-known linear algorithm is principal component analysis as dimensionality reduction method. But that was my first choice for this session. But as our matrix is huge, and we left from previous session around 105,000 samples of reviews, and feature space engrams of those reviews were around 900,000. So we had a large matrix for training for today. Principal component analysis doesn't support sparse matrices. And by documentation recommendation, if we work with the sparse matrices, we should use truncated singular value decomposition. So I changed from PCA to SVD for today's session as representative for linear dimensionality reduction algorithms. On non-linear dimensionality reductions algorithms, choice is pretty much lower. And beside of that, it's pretty much lower. Huge part of those algorithms are in just visualizing purposes, data visualizing purposes. So a huge part of them doesn't have splitted fit and transform functions. So that basically means that every time when we want to analyze some text, we need to learn or rerun those algorithms to be able to convert or to reduce dimensionality of data. In our case, that should not work because in a problem setup from previous session, we said we are preparing ourselves for data streaming in millions of reviews per day. So rerun and retrain those algorithms every time when we watch and analyze will not work well. So basically, we left with the choice between ISOMAP, local linear embedding, and kernel PCA. ISOMAP have an option to work with the sparse matrices, so I choose the ISOMAP for today's session as a representative for nonlinear algorithms. And one of the very interesting modern approaches to reduce dimensionality with the neural networks are embedding layers. But embedding layers are usually used inside neural network architecture as a first layer after input layer. And today, our task is unsupervised learning. So we want to apply some clustering, not neural network model. And I decided to make embedding or autoencoder, as usually is called, our custom one. So how that works? Basically, autoencoders worked like converting problem in fake supervised learning. So they take input and they predict as output that same input. If we want to make architecture to reduce to use it in purposes of reduced space, we need to make something called bottleneck in architecture. That bottleneck basically means that if everything passed well and network learned to accurately predict input by itself. On that middle bottleneck layer, we will have weight representations on lower dimension of those that same input. So basically, if we run a network on this manner, we can use that encoder part. We can cut off that encoder part and use it as a dimensionality reduction algorithm for ourselves. So here I showed you what and how I applied it. Basically, I made 5 layers, 5 main layers. Middle layer is bottleneck. Here I made, later I will show you results in 3-dimensional space. I made 3 nodes because I want 3-dimensional space, and this layer is something similar by syntax as in sklearn number components parameter. So how many components you want, you put that many nodes in that layer. After, in a second method here, below, I extracted this first encoder part from already trained network and use it to reduce dimensionality for text, for reviews, which I use in analysis. As quality of dimensionality reduction directly impact on the quality of clustering later, I decided to make a little experiment and to see and visualize for myself and for you how look like a result of those different algorithms. We said we will use SVD, ISOMAP, neural network reduction encoder, and I also include the most popular visualization method, TSNA, to show you and compare results of all those 4 dimensionality reduction algorithms. So these were results which we get applying those techniques. Maybe I will try now to run them and show you in a live how space look like and how features look like in space when we run it. Give me 1 second. Okay, let's start from SVD. Let me see how to switch screen also. Hello. Do you hear me still?
Yeah.
Something with the Zoom happened. Just a couple moments. Try to find a way how to new share. Okay, that's it. Do you see a figure 4?
Yeah.
Yeah. Okay. Dimensionality reduction T snare left in the title. I will change it later. Basically, these are results which we get applying SVD. What is specific for this data set? I wanted to compare how algorithms are able to and how in space look like reviews which are sentiment separated but on same topic, and how look like for completely different topics. So our magenta dots are just clothes about some jeans, or as I remember, or something reviews. And blue and green dots are electronic reviews about some Samsung SD memory cards, but positive and negative. Greens are negative, blues are positive. So if we closer look those results, we will see that basically separating text reviews by topic is pretty good. We have clear cluster of cloud reviews and cluster of electronic reviews. But on the other hand, on electronic reviews, separating positive and negative are pretty hard. So if this is output of SVD, or any clustering algorithm, we will have a problem to split them and find them in different clusters. Let me show you now one more example. Now we will see how it's look like with a neural network, for example.
Ognian, but the screen is unavailable for now.
Yeah, I'm switching a screen now. That's a specific of Zoom. Okay, and these were results of our embedding layer from neural network. He also succeed to split very well different topics, and maybe in some dimension there is a difference between positive and negative reviews, but also I believe it was very hard to distinguish those two types of reviews. Here is not a bad example. I maybe I am biased. I see green are below, blues are a little higher. That was output of neural network embeddings. And one more, let's see how TSNA works on this data set. Okay. Yeah, that here are results of TSNA. I believe he's maybe best one because we have clear center of one topic, and green are and blue are pretty well separated. But bad news is that we cannot use TSNA for our clustering algorithms. So that's just for visualizing purposes. Okay, that was that for dimensionality reduction algorithms. So let's continue on next step. Okay, After dimensionality reduction, we need to choose between which kind of clustering algorithm we will apply. Actually, today exist more than 18 families or categories of clustering algorithms with 50 plus algorithms in available algorithms. I will send you, I will attach that list in material, in documentation of this session. And for today's session, I will choose between two most popular and most used categories. That's categories of algorithms based on partition and on hierarchy. So most popular ones are k-means and Birch. So basically, we set it up algorithms. We have dimensionality reduction methods. I run them, and let me tell you some preliminary conclusions which I had when I applied all of that. Actually, neural networks was good experiment, but on a practice I couldn't succeed to apply it because our really high dimensional data produced really large metric, really large architecture, and that was too much for my laptop and its memory, so I couldn't successfully apply neural network embedding layers. Also, I was pretty struggled with the isomap as nonlinear representative because he learned for an hour, I believe. He learned representations of vectors, text vectors in a lower space. So we will left with the two algorithms for clustering, Birch and k-means, and isomap and SVD. After applying those techniques, these were results which we get. K-means had pretty well speed with the SVD. It was really fast. And also its results were like not really bad. I must admit you, I expected very low capability of clustering algorithms after that experiment with the visualization of dimensionality reduction results. But when I saw first results on applying those algorithms, I was pretty surprised. K-means with the SVD had about 76, 78% of accuracy. Birch was maybe on the same level with the SVD. Results are more or less same, but main thing which make me to pay attention is that all algorithms succeeded to capture proportions between positive and negative reviews. If we see in the support or below, I extracted true negative and true positive samples. We have some proportion like 85-15 positive negative reviews, and almost all algorithms were more or less in that range, 19-10, 75-25. But basically they captured that disbalance, and they were pretty close to describe sentiment of those reviews which we cluster. So that's it for applying clustering algorithms. I didn't spend much time on tuning. Basically, everything was applied almost out of the box. And more or less results was satisfying. Um, as we said, after unsupervised learning techniques, we prepare to talk about applying our supervised learning techniques, pre-trained models on unsupervised learning problems. So if you remember, I told you on previous session, we trained our supervised learning models on pet foods sample review, pet foods reviews sample. There's a topic about, let's say, food, but not human one. I wanted to make like evaluation of our supervised learning technique on something similar, some similar topic, and I found around 1,000 samples of reviews of restaurant reviews. So I was curious how well supervised learning models trained on pet foods will be able to predict sentiment of people which reviewed restaurants. So when I applied our LightGBM model from supervised learning session, I got about 80% accuracy applying model which is trained on pet foods. This is, for my opinion, not bad, you know, at all. 80% on pretty much different things, similar but pretty much different. At least good baseline for tuning and developing something more accurate. Also, I decided to apply other two techniques which we used in this natural language processing session. If you remember, we also, beside our pipeline and our models in a supervised learning, we applied NLTK pre-trained models as well. So I decided to make some comparison of all those techniques which we used in those our two sessions. So after applying all those techniques, I got results like this. You already see LightGBM have about 80% accuracy, NLTK have 81. And unsupervised pretty much underperformed this data set. So in the previous data set, unsupervised models pretty well described imbalance in positive and negative reviews. Basically, they captured sentiment more or less, but on this data set, they didn't perform well. And basically, this makes me to conclude on conclusion that if we have unsupervised problem as our task, probably we should do as much as we can to convert it in a supervised, to learn or to find some data set that named supervised learning model on similar topics. Maybe if we need really fast results and we don't have a time to develop anything from ourselves, also NLTK pre-trained model appears to be pretty confident in its results and so on. But if we really don't have a choice, then probably we should prepare for hard work to make unsupervised models to work well on, and I must say, on sentiment analysis clustering. Probably for some other tasks like topic clustering or something like that, they should work much better, as we saw in dimensionality reduction visualization, it's pretty much easier to distinguish different topics than different sentiment. But generally, on this session, we predicted sentiment, and I decided to show you clear results what is going on that field. Also, in a couple talks with Tatiana, we had an ideas with maybe even converting unsupervised learning to semi-supervised semi-supervised learning problem, where we can split our data sets in many clusters, then on some way give a little hint, for example, to our algorithms which cluster should be how labeled. But that require more time for analysis and development, and for today's session, I couldn't succeed to make them and show you results of that approach. So basically, that's more or less it for those pipelines. Please, if you have any questions or maybe your thoughts about these methodologies,